Hey everyone, this is a quick review of key things to know for trig parts in calculus based on the unit circle. There are shortcuts, there are memory tricks like the square root thing with the 43210. That can get you a right answer and sometimes quite quickly, but it doesn't lead to a conceptual understanding of really where these ideas come from. So I think it's really helpful to sort of see it. This is hopefully going to be just a short summary of all the key things you need to know. So with a unit circle, guess what? Your radius is 1. That's where the unit comes from, 1 unit. So the radius to one of these, any one of these points, the radius is just 1 unit length. That is fundamental because what it means is that some angle theta, and we start with theta at 0 here, and we rotate around counterclockwise to get to our other points on the unit circle. If the radius is 1, the diameter then is 2, and the distance around the entire circle is 2 pi. That means half the way around is pi. There is a movement out there to change the way we think of this and give it a new name, not pi, but tau, and to call all the way around being tau, and that's the number you multiply the radius by to get the circumference. But for now, we're sort of stuck doing it the way we've done it for most of the last century, with this unit circle being 0, pi is halfway around, and 2 pi is all the way around. We can fill in these coordinates really easily. This is the coordinate 1, 0, because we go out 1 to right here and up and down nothing. This coordinate right here on the unit circle is left and right 0 and up 1. This then is -1, 0, and this is 0, -1. Those are like north, south, east, west coordinates. Dead easy. Okay, well, if we divide up our circle by fractions, this is half of pi, and this is 3 pi over 2, and then we can divide half of half would get us to right here. This is pi over 4. 1/3 of the way to 90 degrees is 1/6 of the way around, so this is pi over 6. You should know all of this, pi over 3. Then all we really need to know is 3 numbers. We need to know that if they're equal, and these coordinates x and y are equal, we can solve Pythagorean style and find out, once we've simplified the fraction, that it's √2/2. These are these equal coordinates. So 2 equal coordinates, we use √2. That's how I try to remember it. If we've got a 30-degree angle, or a 1/6 of pi, it's going to be out √3/2 and up 1/2. Okay, well, this is longer, so I try to think of that as the longer leg. That's got the √3. And then the shorter one, I find it convenient to know that that's halfway up. That's a nice, convenient 1/2. These are the only 3 numbers, the √2 and the √3 and the 1, and we just rearrange them to get all the other points with pluses and minuses. So this is out the short amount, 1/2, and up then the long amount, √3/2. And then you just need to know your symmetries to find all the other points. This one's symmetrically opposite pi over 4, so that's 3 pi over 4. And this is the one that's then 1/3 again from here, so that's 2/3, 2 pi over 3. And then if you can say, well, that's 1/6 of pi up, then this should be 1/6 of the pi back, so this is 5/6 pi. So all of these points you can fill in with fractions. Just get familiar with those fractions. This is 11 pi over 6, for instance. This is 7 pi over 4, and this is then 4 pi over 3. And you can fill them in, and then the coordinates, you can just know that it's going to be, out the long distance and then down the shorter distance, that 1/2. So the coordinates here then would be √3/2 and -1/2. Now, fundamental to this is the understanding that the cosine value is that left and right, that x coordinate. The sine value is then the y coordinate. And then tangent is a ratio of the sine over the cosine, always the second coordinate over the first coordinate. So if you can picture this, you can say, oh, the tangent then here is going to be 1/2 over √3. The 2's will cancel, and the tangent value here is 1 over √3. So we can use this knowledge of the unit circle to solve some pretty straightforward questions. like these, all right? So what is the sine of pi over 6? You can just picture that. Oh yeah, go up there and you can say, oh yeah, the sine of that is 1/2. That's the up and down amount on my first point on my unit circle. What's the cosine of 7 pi over 4? Pause it for a sec. Okay, here's 7 pi over 4, and the cosine value is going to be the x amount, so that's just going to be root 2 over 2. If it was the sine value, it would be negative root 2 over 2 to come down to here. So what is the tangent of 7 pi over 6? That's going to be at this point right here. So the tangent is the sine, that's the y value, that's negative 1/2, over the x value, which is negative root 3 over 2. The 2's cancel, the negatives cancel, and that would be 1 over root 3. We generally do not rationalize that denominator. We do not multiply by root 3 over 3. But if we did, we'd see that it's also the same as root 3 over 3. And some books might want you to do it that way. Again, another quick practice problem. Pause and try this. Oh, that's just 3 pi over 2. The sine value is the down amount, so that's negative 1. Now, inverse sine. Now we can do things in reverse. We can take the coordinates and find the angle that would give you that, value, but we need to understand our restricted domain. So the sine value, we're only looking at points along this part of the unit circle from negative pi over 2, that's the same as 3 pi over 2, to positive pi over 2. That's for the sine and the tangent. The cosine value, we use the top half of the circle, and that means we're going from 0 to pi. All right? So to do a question like this, as there might be in any textbook exercise, what's the inverse sine of root 3 over 2? Well, when that's a positive value, so in this part of the unit circle, where are we going to get to positive root 3 over 2? That's the long amount. That's up here. That's clearly going to be pi over 3. Oops, sorry, I dropped that off. It's the top value here will be the long amount up, so it's going to be pi over 3. The secant, the inverse secant of 2, that's saying, well, when is, if I invert both of these, that's the cosine value. When is that going to be 1/2? That's the same thing, because the secant is 1 over cosine, and 1/2 inverted is 2. So when is this going to be the case? Well, that's going to be when my cosine value is going to be halfway, and that's also going to be at pi over 3, that my cosine value is a positive 1/2. Now we're doing sort of a combination problem. The arc sine is the same as the sine to the minus 1, same exact thing. If I do the inverse sine of 1/2, when do I get 1/2? Oh yeah, that's, have we done that one already? That's up here. That's at pi over 6. And what's the cosine of pi over 6? That's going to be root 3 over 2. All right. What's the tangent of the inverse sine of 2/3? Okay, so in this case, inverse sine of 2/3, we need to make a little right triangle and say, if I have a triangle that hits 2/3 of the way up, it would be an angle something like that, okay? And I'm restricting it to only this part of the circle, because we could have another value over here, but that's not allowed, because our sine value, when we're doing an inverse sine function, we're only looking at the first and the fourth quadrant. All right, well, when is that going to be 2/3? It's when this opposite side is 2/3, and it's in ratio over 1. And then I can solve using Pythagoras for the cosine value. So the cosine is going to be the square root of 1 minus 2/3 squared. So that would be 4/9. So that means it's going to be the square root of 5 over the square root of 9, because I'll subtract 4/9 from 1, which is 9/9. I'll get 5/9, and I take the square root and I get 3. So that's your cosine value. And we want, though, the tangent, so that's going to be sine over cosine. So it's going to be 2/3, oops, I keep dropping that off in the camera, I'm sorry everybody, 2/3 over root 5 over 3, so it's going to be 2 over root 5. 2 over root 5, okay, by making a triangle, solving for cosine, and then putting the ratio there.